Alright, in this problem we're asked to calculate the heat involved in taking 40 grams of ice from 0 degrees C to 80 degrees C. So we're going to have to melt the ice to liquid water and then heat the liquid water from 0 degrees C to 80 degrees C. Alright, so there's two processes. We have a phase change process and a delta T process. The constants that we need are all given here in the statement of the question. So we just set up our problems and churn out our answer. In the first part of this problem, we're going to have to incorporate the delta H of fusion of water. It's given to us in kilojoules per mole, so we're going to have to be aware of that as we work through our units. Grams cancel. We're going to have to convert the mass of water to moles so that we can get the moles to cancel. Now we have units of kilojoules, and we want to convert those to joules so we can add the results of these two calculations. So we convert kilojoules to joules. Alright, so we have our calculation of joules for the first process, melting the ice at 0 degrees C to liquid water at 0 degrees C. We're going to keep some extra sig figs until the end of the problem. For the second part, heat is going to be mass times specific heat times delta T. Delta T is always TF minus T0. And when we chunk out our, well, let's look at our units. When we look at our units, we see grams cancel, degrees C cancel, and we end up with units of joules surviving. And our amount of heat for the second step is 13,389. Now we need to add these two processes, the heat involved for each of these processes together to get to our final answer. Alright, we've added these two values together to get our final answer in terms of joules. We need to go back and worry about our sig figs. In each step, we see that we're going to be limited to 2 sig figs by the mass of our sample. So we'll have to limit ourselves to 2 sig figs here and here. So if we indicate where our sig figs are in our problem here, we see it's just these first two columns. So when we round off our answer, we can't go beyond the thousandths place. So to convert this to joules, we're going to have 27,000 joules. We need to express that in scientific notation, 2.7 times 10 to the 4th joules. Or we could get away with not using sig fig at all if we convert this to kilojoules. So if we divide this by 1,000, we see the total energy that's going to be involved is 27 kilojoules.